Today we're going to talk about functions and graphs and drawing linear and possibly quadratic graphs. All a function is a rule that relates one set of numbers to another. We've come across these when we've talked about proportionality and then put the equality sign in and related values of x's to values of y. We've also talked about these when we've talked about nth term and related how the nth term is changing with a b number at the beginning. We can represent all functions with equations. You've come across these again when we've talked about function machines and things like that. Today we're going to plot these things on a graph. When we're plotting functions and graphs, we use a coordinate system. We have the x-axis going across the page, and we have the y-axis going up and down the page. The centre where the x and y-axis cross is called the origin, and we usually label that with the coordinates 0, 0. As you can see, we write coordinates in pairs of numbers with brackets around them. The first coordinate is the x coordinate, and then the second coordinate is the y coordinate. So we read along the x-axis and then go up the y-axis. You might have heard along the corridor and up the stairs. If we wanted to plot these points, 2, 1, we would start at the origin, go 2 along and 1 up, and mark across here. If we wanted to plot the point -3, 4, we'd go -3 in the x direction and then 4 in the y direction and plot a point here. I seem to be having a problem with the PowerPoint. Have a go at plotting the other two coordinates. The coordinate -2, -3, we'd go 2 along the x-axis and then 3 down the y-axis, and it would be here. And 4, -1, we'd start at the origin again, go 4 along the x-axis and 1 down the y-axis, and it would be here. Now everything is done from the origin. When we want to plot some linear graphs, we will be given some points, or we have to work out the points, and then we work out the coordinates we need and plot the graph. Here we've been given some points. The x coordinates are 0, 2, 4 and 6, and the y values and coordinates are 2, 5, 8 and 11. So we plot the coordinate 0, 2 and then 2, 5 and 4, 8 and 6, 11 as required. Here 0, 2 is here, 2, 5 is here, 4, 8 would be up here somewhere, etc. And when we've done that, we draw a nice straight line intersecting all the points. Notice linear graphs are always straight lines. We can use graphs to do conversions. These are called conversion graphs. It shows how one quantity changes with another quantity. So that could be miles along one axis and kilometers up another. It could be temperature between centigrade and Fahrenheit. You might get a currency conversion chart showing you changes in pounds and dollars or pounds and euros, things like that. The other type of graph that comes up is distance and time graphs, a graph showing how far away from a certain point somebody is and how long they've been travelling. Here you can see that they start at 0 and in 15 minutes they travel 1.5 kilometers. What does this flat line mean? It means that they are not moving any distance away, so they must be standing still or stopped. And here you can see they've stopped for 10 minutes. Then they've continued their journey, and between 25 minutes and 40 minutes they got to 3 kilometers away. And then what does this line mean? Well, it means that between 40 minutes and 55 minutes their distance is decreasing, so they end up back where they started, and the total time has taken 55 minutes. You need to be able to explain these types of graphs with these types of things in them and show what it all means. Given a function to plot, that is y dependent on some x values, what you need to do is choose at least 3 values. 3 values will give you a straight line if you've calculated them correctly. You can use 5 values, but that's a little bit of overkill. What we do is we take x values that we're going to determine and find out what the y value is, get ourselves 3 coordinates, and then plot them on a graph. This is the function y equals x minus 2. We're going to try and plot this. So what we do is take 3 x values. Now keep it easy. You don't need to do anything overcomplicated, but best to maybe use 0 for x, a positive value and a negative value. So that's what I've done here. I've taken x as minus 2, 0 and 2. We all love negative numbers, don't we? So I always start with the positive ones. And what we do now is substitute, which we did the other week, back into this equation when x is 2. So we put x is 2 in here and we get 2 minus 2, which is 0. So our y value is 0. So we write that into here. We then do 0 when x is 0. 0 minus 2 gives us minus 2. And then finally we do our negative value, minus 2. When x is minus 2 take away another 2 gives us minus 4. So now we have our 3 coordinates, minus 2, minus 4, 0, minus 2, and 2, 0. And then we can plot these on our graph. Minus 2, minus 4, 0, minus 2, and 2, 0. That is enough to give us this straight line, which we can then extend both sides of the coordinates we used. Another thing they like you to do is to plot or find the midpoint of a line segment. A line segment just means that the line has 2 endpoints. On this one it's here and here. We can see the coordinates of this endpoint are minus 3, minus 1, and this endpoint are 3, 3. And basically what you're trying to do is find, well, where's the midpoint? You could probably see it, that it's obviously here, but how would you work that out given a general line? Well, basically what we do is we take the average of the x coordinates and the average of the y coordinates. So if we take the average or mean of these two numbers, this x coordinate is minus 3 and this x coordinate is 3. And the average will be minus 3 plus 3 all divided by 2. So we get minus 3 plus 3 divided by 2. Well, minus 3 plus 3 is 0, and 0 divided by 2 is 0. For the y coordinates, we have the minus 1 and we have a plus 3. So basically we have 3 minus 1. 3 minus 1 is 2. Divide that by 2 and we get 1. And that is this 1 here. So the coordinate of the midpoint is 0, 1. This equation is how you do it. It looks a little bit complicated, but basically what we've done is take the two x values, add them together and divide by 2, and the two y values, add them together and divide by 2. And that gives us our midpoint. Now we talk about this equation here, y equals m times x plus c. This is usually the normal way of writing the general form of a linear equation. The m stands for the gradient of the line, how much is it going up by or down by, and the c represents the intercept. That is the point where it crosses the y-axis. The gradient or slope of the line is given by how much does the line change in the y direction divided by how much does it change in the x direction. Sometimes this direction in the y direction is the run, sorry, that's the rise, and in the x direction it's the run, and we say the gradient is the rise divided by the run, or the change in y divided by the change in x. We'll show you an example of that in a minute. Okay, so let's look at this line here. We can see that it crosses the y-axis at the point 0, 2, so that tells us immediately that the intercept value, the c, equals 2. We need to work out the gradient of this line, and we work out the change in y divided by the change in x. When you're doing this, the best thing to do is to look for some easy triangles. Here we've got a triangle here from -2 to 0 and 0 to 2. Or you could take a bigger triangle. Here we could go from -2 to 4 and then from 0 up to 6. They will give the same answer. As this is a straight line, these triangles are all similar. Do you remember we talked about similar triangles in a previous session? So if I'm going to use this little triangle here, from -2 to 2, then the change in y, it goes from 0 to 2, which is 2, and while it's changing from 0 to 2 in the y direction, it's changing from -2 to 0, which is a change of 2 in the x direction. So the change in y is 2, and the change in x is 2, and 2 divided by 2 equals 1. So I can write the equation of this line as y equals 1 lot of x plus 2. And we know that when we're doing algebra, we always ignore the 1, and we just write y equals x plus 2. And finally, just a couple of things to talk about. If lines are parallel, then you can see they've got the same gradient, the slope is the same, but they'll have different intercepts. And this comes up in the exams quite a lot. They'll give you the equation of a straight line and say, write down the equation of a straight line that is parallel to this one. Well, if you know what the gradient is, you can write that down immediately, and you just choose a different intercept, i.e. where it crosses the y-axis, and everything's hunky-dory. For straight lines, gradients that go from the bottom left to the top right, i.e. are increasing or going across and up, they're positive gradients. If you've got a straight line that's coming down like this, it has a negative gradient. For a line that's going straight up, well, basically it's an infinite gradient, but we can still write the equation of the line down. On this line here, all the y values are different, but the x value is always -2. So even though this line is going in the same direction as the y-axis, we call this line here x equals -2. Similarly, if we look at all the points along this line here, this horizontal line which has a 0 gradient, we can see that every x-coordinate changes, but the y-coordinate is always 2. So we call this line y equals 2.